Open Data Kit is a set of tools to help you collect, aggregate, and author forms for collecting your data. ODK Collect is an Android app for filling in forms. Forms can contain multimedia, including images, audio, and video. In addition, the collected data can include locations, barcodes, and sketch annotations. ODK Aggregate runs on a server and is the repository of the data sent by ODK Collect. The data can be viewed in spreadsheets and on maps. The ODK Aggregate server can run in the cloud, on a virtual machine, or on a private server under your desk. Data on the server can be exported to a variety of other tools, including Google Fusion Tables, Google Earth, and Google Maps. ODK includes two form authoring tools. Build is a graphical drag-and-drop tool for creating simpler forms. XLS Form allows larger forms to be laid out in a spreadsheet using Microsoft Excel. Let's go through a simple example from an ODK user in Pakistan. The government of Punjab Health Department uses ODK to track the workload, staffing, and available medical supplies at local health clinics to identify shortages and staffing problems. This is an example XLS form used for this application. We want to record the number of antenatal visits that this clinic performed, so we're going to add this as a question to the form. We want the answer to this question to be a number. We will name this value antenatal, and we will require that the user answer this question before proceeding. The text of the prompt will be antenatal visits last month. Great, that's done. Now we will check on a question that asks about available tablets at this clinic. This is a select multiple question, which means that the user can input multiple choices. The available choices are stored on a second worksheet, highlighted here. This is how the XLS form renders on the phone. We will now show you how to fill in the form. Here we can see the tablet choices that we highlighted earlier. And here is our question about the number of antenatal visits that were performed last month. Here we're adding a photo that we took to the form. Now we're going to record a GPS location. After completing the form, we can send it to our cloud server at our convenience. The delay is proportional to the size of the photo that we added. Now, let's go to our server to see the data that we sent. First, we need to log in. Here, we can see all of the data that has been uploaded. Let's visualize our data on a map. Each point represents a form that was submitted. We can select points on the map and view the data associated with that form submission. Now, let's look at some of the photos that were added to the forms. The data has now been exported to a Government of Punjab website, where, for example, we can look at which clinics had stockouts of specific tablets this month. There are several other ODK tools that you can find on our website. We will now highlight two of these tools, ODK Scan and ODK Sensors. In locations with limited access to electricity and internet connection, paper remains the primary vehicle for data collection. Manually transcribing this paper-based data is difficult, although the benefits of digitizing data for statistical analysis and aggregation are significant. ODK Scan is a tool that can automatically digitize data recorded on paper forms. Scan is capable of running entirely on a mobile device and does not require a reliable power source or internet connection. To create scannable paper forms, we provide a tool that can automatically convert an Excel spreadsheet into a form that can be printed by any printer. This tool is very similar to the XLS tool described earlier in this video. To use Scan, the first step is to capture a picture of the form. This is done using the standard Android camera app that comes with your phone. Position the form beneath the camera and take a picture. If the image of the form looks good, press OK to accept the image. Scan then locates and aligns the captured form image. After the form is aligned, data is extracted from the image. Bubbles and checkboxes are automatically classified as filled or empty, and the results are shown on the screen. After the bubbles and checkboxes have been digitized, the data is exported to ODK Collect. Since Scan cannot interpret handwritten text, we make it easy for people to type in this data by displaying an image snippet on the screen with the text entry box. This means that once the form image has been captured, the user does not need to refer to the physical paper form anymore. Instead, you can simply look at the screen and type in what you see. Scan will autofill the values for fields that it read automatically, so you can check these values if necessary. Finally, all the collected information can be stored on the phone and uploaded to a database like ODK Aggregate if an internet connection becomes available. We have also created a desktop version of ODK Scan for people who would rather use computers to digitize their paper forms. On the desktop version, you can digitize many paper forms at the same time. Scan is currently being used by health district managers in Mozambique to digitize data related to the consumption of medical supplies. The app can handle many different lighting conditions, different pens and pencils, and many different styles of form filling. The ODK Sensors framework simplifies connecting sensors to mobile devices over communication channels like Bluetooth, Wi-Fi, and USB. Using ODK Sensors, we have developed an Android app to monitor pasteurization of breast milk. This app is being used in South Africa to safely pasteurize donor breast milk and kill pathogens like HIV. The pasteurized milk is fed to babies who are unable to get breast milk from their own mothers. In this system, a temperature probe, placed inside a glass jar, is connected to an interfacing device called Phone Astra. Phone Astra sends temperature readings to the Android app over a Bluetooth connection. The app guides users through the pasteurization process based on these readings. Glass jars of breast milk are placed in a stand with a jar of water that contains a temperature probe. The stand is placed in a pan of water which is placed on a stove. To begin the pasteurization process, the user first enters donor information, including a donor ID, the type of milk, which could be term or preterm, and an expiry date for the pasteurized milk. After entering donor information, they go to the temperature monitoring screen of the app. They turn the stove on and click the Start button of the mobile app. This establishes a Bluetooth connection between the phone and Phone Astra, and the app now displays temperatures received from the device. Just before the temperature gets too high, the app beeps to alert the user. When the milk reaches the target temperature, the app beeps continuously until the user moves the stand to a cool water basin. After a short while, the app beeps again and prompts the user to add ice packs. The procedure is complete when the app detects that the milk is cool enough. The user can then print a pasteurization report and labels for milk bottles using a Bluetooth-enabled printer. mobile app also uploads the temperature data to a server for review by supervisors. Supervisors can remotely access the server using an internet browser. The main page shows a summary of all the milk banks. Clicking on a milk bank displays a page that lists all the procedures performed at the facility. Clicking on a procedure brings up a page that displays a temperature curve and summary data for that procedure. That concludes our tour of the ODK Toolkit. All of the ODK tools are free and open source and available from our website at opendatakit.org. There are also several companies based in the developed and developing world that offer value-added services and customizations of the ODK Toolkit. ODK is being used around the world by thousands of people, contributing to hundreds of projects in dozens of countries. Thank you for your attention.